Identity and Access Management on AWS. IAM is a core AWS service that helps you control access to AWS resources. We will go over following IAM related features: accounts, users, groups, roles, authentication, authorization, policies, cross-account access, multi-account strategy, identity federation, and directory services. What is an account? When you first sign up with AWS using your contact information and payment method, what you get is an account, and you become its first user, the root user. All your AWS resources will exist in the account. As a root user, you have complete control over the account. You can manage the account in all aspects and create other users. Some security tips with respect to the root user. Safeguard your root credentials and don't use them for everyday tasks. Create other users with appropriate privileges for everyday tasks. Configure MFA or multi-factor authentication for your root user. Don't generate access keys for the root user. IAM allows you to define identities like users, groups, and roles. User is an individual, group is simply a collection of users, and roles are permission sets that can be granted temporarily to other users, groups, or entities. Groups, as we know, are a collection of IAM users. An IAM user can belong to multiple groups. Policies or permissions can be granted to a group which percolate down to users in that group. What is a role? It is a set of permissions that grants temporary access to resources in AWS. Anyone that assumes a role gets permissions associated with it. It provides temporary permissions. Roles are defined as policies or JSON documents. A role is made up of permission policy and a trust policy. Trust policy on a role defines who can assume that role. Authentication is the process of verifying the identity of a user. An IAM user can be authenticated in many ways. On AWS console using username and password. On CLI with access key. For API requests, you can sign the request using access key. Access keys are made up of access key ID and secret access key. They are associated with IAM user and are used for programmatic access to AWS services. Authorization is a permission check or verification of access rights to resources. It is defined using policies. Policies are JSON documents that specify permissions. They are attached to users, groups, roles, or resources. Policies can be categorized as identity-based or resource-based. Identity-based policies are assigned to users, groups, or roles. Resource-based policies are attached to AWS resources such as S3 buckets. Policies can also be categorized as managed or inline. A managed policy is a standalone policy. It could be AWS managed or customer managed. It has its own ARN or Amazon resource name. Inline policy, on the other hand, is embedded in an IAM identity. It does not have ARN of its own. Let's take a look at a policy example. This is a JSON document. Note the effect, action, and resource keywords. Effect could be allow or deny. In this case, it is an allow, while actions here are applicable operations. In this case, list bucket, get object, and put object on S3. Resource refers to the entity on which actions are applicable. In this case, example bucket. Therefore, this policy, when attached to a user, allows list, get, and put actions by the user on example bucket. Here are some quick policy evaluation rules. All permissions are implicitly denied by default. An explicit allow in an identity-based or resource-based policy overrides this default. An explicit deny in any policy overrides any allows. If both identity and resource-based policies are applicable, here is how effective permissions are arrived at. Let's learn about permission boundaries. These are used to set maximum permission that an identity-based policy can grant to an IAM entity. Let's understand this with an example. User X is part of a group that has full admin rights. A permission boundary attached to the user X restricts access to only S3. Result, user X only has S3 access, as permission boundary does not allow any other rights to take effect. If both identity-based policy and permission boundary is applicable, here is how effective permissions are arrived at. You can have more than one account to manage your workloads. Let's take a look at what is the best way to organize this. Using AWS Control Tower service, you can create and manage multiple accounts. The paying account that you begin with is called a management account. When logged into management account and using Control Tower service, you can create organization units or OUs. These could be your business departments like sales, marketing, manufacturing, or perhaps projects. In our example, we have Project 1, Project 2, and Security as our organization units. Within each organization unit, you can create accounts. So, Project 1 has a development account and a production account. Similarly, for Project 2 OU, while Security OU has a logging archive and an audit account. Remember that these accounts can exist directly under management account too, and having them inside an organization unit is not necessary. You are not limited to creating accounts from within AWS Control Tower. You can even invite existing independent accounts to join this organization structure. You can also restrict services available in accounts here by applying service control policies or SCPs to organization units or accounts. Overall organization billing, that is for all accounts, is handled by the management account. You can still view the costs incurred in each account. This kind of multi-account strategy allows you to isolate workloads and environments from each other and helps you better meet security, compliance, and budget needs. If both identity-based policy and service control policy are applicable, here is how effective permissions are arrived at. Cross-account access. How do you allow users in one account access AWS services in another account? Let's say we have two accounts A and B. Account A has an S3 bucket called example bucket. A user in account B must be allowed to access the example bucket. This is a cross-account access scenario. For this, we need to create a role. Let's call it example bucket access role in account A, granting S3 bucket access. Remember that a role is made up of permission policy and a trust policy. We will learn more about this shortly. In account B, create a policy attached to the user to allow the user to assume the example bucket access role. Let's take a look at what these policies look like. Example bucket access role policy is shown here. There is a permission policy and a trust policy in the role. Permission policy reads as allow list bucket, get object and put object operations on example bucket. Trust policy reads as allow account B user to assume this role. In other words, account B user is trusted to assume this role. Therefore, if a user of account B assumes example bucket access role, he will gain access to the example bucket. Now, in account B, we need to allow a user to assume example bucket access role. This policy reads as allow this user to invoke STS assume role for the example bucket access role. Attach this policy to the account B user that needs access to the example bucket in account A. Now we are done. This will allow the account B user to switch role to example bucket access role and thus access the example bucket. Let's take a look at identity federation. Identity federation is the process of delegating authentication responsibility to a trusted external party. It consists of identity provider that maintains and authenticates users and service provider that provides services to the users. Trusted identity providers can be on-premise federation services, corporate directories, social identity providers like Google, Facebook, Twitter, etc. Two kinds of identity federations are popular: SAML-based identity federation and web identity federation. Let's review SAML-based identity federation. SAML-based identity federation is supported by identity providers like Active Directory. If corporate users that exist in an on-premise Active Directory need to access AWS services, we would use SAML-based identity federation. Two kinds of access to AWS services may be needed: AWS Console Access, which is a web-based single sign-on from your organization, or API access to AWS. To set up SAML-based federation, configure your identity provider like Active Directory to include AWS-specific claims in SAML assertion. And in AWS, create SAML-based identity provider and a IAM role with SAML-based identity provider in trust policy. Our use case here is a corporate user needs access to AWS console. This user does not exist in AWS IAM. Let's go over steps involved in AWS console access via SAML federation. Step 1. User browses to identity provider page, and in step 2, authenticates against the LDAP identity store. Step 3. Identity provider returns SAML assertion to the client app. Step 4. Client posts SAML assertion to AWS sign-in URL. Step 5. STS or Secure Token Service validates the SAML assertion and returns a secure token. Step 6. Client receives STS token. Step 7. Client gains access to AWS Management Console and other AWS services allowed by the STS token. Our next use case is a client app needs access to AWS S3 bucket via an API. Now, let's go over steps involved in AWS API access via SAML federation. Here we want to access a S3 bucket via an API. Step 1. Client app makes an authentication request to identity provider. Step 2. Identity provider authenticates user against LDAP identity store. Step 3. Identity provider sends client a SAML assertion. Step 4. Client app calls assume role with SAML function on AWS STS service. Step 5. STS verifies the SAML assertion and returns a STS token. Step 6. Client app accesses S3 bucket successfully. Web Identity Federation allows users in web identity providers like Facebook, Twitter, Google, etc. to access AWS resources. Users gain access to AWS resources after they have successfully authenticated with a web-based identity provider like Facebook, Google, Amazon, etc. Following successful authentication, user receives an authentication code from web identity provider which they can trade for temporary AWS security credentials. To set this up, you configure your app in Web Identity Provider. Create OpenID Connect or OIDC Identity Provider in AWS Management Console. Create IAM role with suitable permissions for each identity provider that you want to support. In our example use case, a mobile application needs access to AWS S3 bucket using a web identity. Let's go over the steps for this use case. Step 1. Client app user authenticates against the identity provider like Facebook, Twitter, etc. Client app receives a web ID token from the identity provider. Step 3. Client app invokes assume role with web identity function on AWS STS along with the web ID token. Step 4. STS verifies the web ID token and returns a temporary STS security token. Step 5. Client app can now access AWS resources allowed by the privileges associated with the security token. Therefore, it can access the S3 bucket now. Let's look at Microsoft Active Directory on AWS. There are two aspects we will discuss here. AWS Managed Microsoft AD, which is a managed implementation of Microsoft Active Directory running on Windows Server, and Active Directory Connector. When you create a managed Microsoft Active Directory in AWS, pair of highly available Windows Server domain controllers are created across subnets in multiple availability zones. You can use this Active Directory to add users, computers, and use it for their authorization. If you also have Microsoft Active Directory on premises, then you can connect that over a VPN and create a trust relationship with Managed AD on AWS. It could be a one-way or two-way trust relationship. This essentially means that users in one AD can authenticate and access resources in another AD. Windows EC2 instances can be securely connected to managed AD. For example, a Windows server or desktop running in Amazon workspaces can be joined to a AD domain. Thus, if you have a domain account, you can log on to those computers. You can also connect to Azure Active Directory and Office 365 using AD Sync and ADFS. This means you can synchronize users and federate identities with Azure and Office 365. ADFS is Active Directory Federation Service, while AD Sync is about synchronization. AWS has many applications and services that support authentication and authorization using AWS Managed Microsoft AD. For example, Amazon Workspaces and Workmail. Let's review how we can use AD Connector. Here we have Microsoft Active Directory running in your corporate office or data center. All your corporate user accounts are with it, and you want them to access services in AWS without recreating these users in AWS IAM. So we can use AWS AD Connector service to connect to on-premises Microsoft Active Directory over VPN or Direct Connect. This allows many different services in AWS to authenticate and authorize against it. For example, Amazon Workspaces, WorkDocs, Workmail. Users can also access AWS Management Console by federated signing. AD identities are mapped to IAM roles. Thus, your corporate identity users can access whatever services are permitted by the IAM roles. You could also have Windows EC2 instances join on-premises AD domain via AD Connector. With this, we come to the end of our discussion. This should give you a good idea of identity and access management on AWS.